what I spoke about in the presentation was where we are spending time in our SaaS engineering, testing and lifecycle management, and how we can save time by automating that process, and finally what we need to demand of the manufacturers in order to automate those processes. In substation automation systems, where we've got unlimited bandwidth, high-powered, low-cost processing power, and lots and software configuration tools, then the new scarcity is time, and that's why it's important. The companies, the utilities, who make most success out of 61850 will be those who squander these resources in order to conserve time. In substation automation systems, when now we have unlimited bandwidth, inexpensive, plentiful software configuration tools, and high-powered, low-cost computing, then the new scarcity is time. And if that's correct, then the companies, the utilities, which are going to be most successful with IEC 61850, are going to be those who spend on those things, who spend on software configuration tools in order to conserve time. At Iberdrola, we don't believe is any wishy-washy economic theory, but it's something that is consistent with reality, because according to our own 2014 internal study, we saw that engineering and testing accounted for more than 50% of the overall life cycle costs of our SaaS system. So that means that the big savings are not on saving on the installed cost of the gateway, the installed cost of the HMI, the installed cost of the IED, or the number of switches, but the savings are made on reducing time. Well, the answer, in short, to how we're going to save time is going to be to industrialise our processes. And we're going to industrialise our processes in a way that's consistent with these project goals. So these are the sort of technical constraints that we will have, which is to be future-proof, to be able to have a design which isn't ad hoc or customised purely for Iberdrola, but one that's exportable to other utilities. We need interoperable substations that can incentivise competition and maintain our prices low. And of course, we need cyber security, as well as one data origin, so that our data is quality. So we have quality data, and that increases the predictability of our outputs and reduces our testing constraints. The first place where we spend a lot of time in Iberdrola is in the engineering process. And in the engineering process of our PAC system uses up about 100 hours per substation. This consists firstly in basic engineering, in interfacing the SaaS system with the electromechanical system, the measurement transformers and the switchgear. And this is not always possible to standardise, especially during renovation work, because it's conditioned by pre-existing plant. Then there is, of course, the selection of the PAC devices, and this can take up to 10 hours on our current system. And previously in Iberdrola, we used a sort of ad hoc integrated HMI and gateway called a UCS, and their configuration was on an ad hoc basis. It required careful engineering, liaison with the manufacturer, and extensive testing. After that, we have the detailed engineering of this single diagram, the cabinet design, the interconnection with the switchgear, and also the preparation of the final configuration files. Looking at either bottom-up or top-down engineering processes, we can still identify that with 61850 we would have even more additional time to spend on our engineering processes. I mean, the lowest time I've heard for the configuration of a gateway is around 4 hours, and the production of SCD files using a standard graphical user interface tool generally involves a lot of user time, whether that's drawing the single line diagram or making the Goose message subscriptions. And finally, we would have to integrate the protection settings, the 61850 CID and binary proprietary files, and then we would have the loading of that file into the device. And if we were to outsource the loading of that file into the device to the switchgear manufacturer as our system integrator, how would we know that we had loaded the right configuration file into the right ID and not to the wrong one? And this brings us to the next exercise, which expends a lot of time and that is the device testing. So a lot of time is spent on device testing, because although we have long recognized that the switchgear manufacturer who is responsible for installing the ID is much faster and resolves problems much quicker during the factory acceptance tests than we could do with the site acceptance tests, we have never been able to optimize the FAT tests in such a way that we could be completely happy to reduce those SAT tests to an absolute minimum. I mean, we still load the final configuration, we still secondary inject every IED during the SAT, and we still apply telecontrol point-to-point tests for the substation gateway and the SCADA system. I mean, how could we possibly know that the configuration that has been loaded and tested by the system integrator is the same configuration that has made it through commissioning? So therefore, separate point-to-point tests need to be carried out for commissioning for the SCADA system, especially because our substation HMI previously used different templates and a different information source from the substation gateway. But then, after our PAC system is installed, we cannot fit and forget, but we still have to spend time during the life cycle of the device, and in some ways, this time burden looks like it could even increase with 61850, with new cybersecurity burdens on the utility. For example, to upgrade the firmware to include a new security patch, or to change the local device passwords after a local access has been made. And then, from a configuration point of view, if we need to change a data set or another part of the ICD file, we would need to reproduce an SCD file and the reconfiguration of all the affected devices, and then go on site with all these new configurations and load them to all the relevant devices. So all of the aforementioned describe lengthy and drawn-out processes, which we would end up with at Iberdrola if we don't act now in order to industrialize and automate our systems. The first thing that we are going to squander resources to spend on in order to industrialize our processes is our central SAS systems, our own configuration repository and database. And this will be the cornerstone of our mixed top-down and bottom-up configuration process. This database essentially does two main things. It houses all the repository of our standardized information, including ICD templates, where it receives all the information that is consistent between the same ID and the same bay type in different substations. But it's also what's going to receive the information that is particular to that substation. It's going to receive information from our GIS and our SCADA systems. It's going to receive the single line diagram, interpret it, know what kind of bay types are going to be for this new substation. And this means that our central systems will have all the information which is consistent per bay type, as well as what is particular to that substation. And of course, this is dependent on a high level of standardization. We have standardization per bay type, which includes not only the data sets, the goose messages, and report control blocks for each IED, but also the bay type and the standardization of the telecontrol signals and the HMI representation for that bay. This means that we will use ICD templates, which will be more like IID files without the IP address and the IED name. And we will use all this information to create one big input for the SCT tool. One challenge for an SCT tool is to guarantee interoperability with devices of different manufacturers. And this interoperability we hope to achieve, we hope to make it easier by putting the absolute maximum of our predefined engineering information in those ICD templates, so that the SCT tool has the absolute minimum of things to do. And another challenge is the interoperability between IEDs. And we hope to guarantee this by imposing flexible product naming on the ID manufacturers. Thus, the suppliers will be handed a specification from Iberdrola for each bay and ID type. And they will have to use this in order to create an ICD template using Iberdrola's own data model. This will not only smooth out interoperability, but it will also allow for interchangeability, meaning that Iberdrola can change one device of one manufacturer for another device of another manufacturer. And this is not a small advantage for a distribution utility looking to outsource this kind of corrective maintenance work either to external contractors or to our own generalised substation maintenance staff, rather than our highly skilled and scarce resource of protection and control engineers. But this is to digress, and to go back to our central systems, which have all the information for configuring the substation, and we'll send all this information to the substation configuration tool. This means that the SSD file, the SCL file, is insufficient. It's not enough to send to the substation configuration tool. Therefore, Iberdrola have had to diverge somewhat from the existing standard. And we have had to define our own XML file, which we call the file CNF. So note here that this includes the SSD file, and it includes the bay coordinates on the bay header line. It also gives a reference to the standardized bay type, where you can see the words here, ETF. We also have another section here, the external file references, or the server IED section. And this is, we are giving the SCT tool the information of what configuration files, what ICD templates, what particular IEDs are going to be used in that substation. Because that's something that can be automated by our central SAS systems. They know from the single line diagram from SCADA what type of bay it is. They know what type of IEDs are standardized for that kind of bay, and they know what kind of ICD templates they need to download. So we can give the SCT tool this extra information. So here we say what configuration files need to be downloaded, and we also make the link to the IED name. So our own central SAS systems will assign an IED name for automatically. Next, we have the networking section. And in the networking section, we have all the communication settings which are included, which need to update the configuration of MMS, IP, and Goose network interfaces in the SCD file. And maybe you are now wondering, how can we automate the Goose engineering, which depends not only on the publishing of the messages, but also on the standardized configuration type, and relies upon the particular topology of that substation to know what has to make the subscriptions. And the answer to this question is that our central SAS systems, again, they know the topology, they can understand it, and then they can make up a Goose matrix using the later binding method, which is in edition 2.1. So we will use ICD files, the templates, as the starting point with the input and xref lines for each Goose message that is permitted. And the SCT tool will assign each input to an actual Goose message. But again, with some differences. Rather than use the internal address, we will use the description field desk in order that the SCT can understand the electrical significance of each signal, so that we can have compatibility between edition 2.1 and edition 2 relays. We will not use the instantiated data object and an instantiated data attribute name in order to distinguish between quality and value, but we'll use the desk field at the data attribute level instead of the data object level. This is because in the edition 2, the instantiated data object and data attribute fields are not available. And the reason that we're using the desk field is because it's a free text field. And a free text field means it's something that Iberdrola, with its own data model, can impose on the manufacturers to use this field according to our own strict standardisation. For example, if we were to use what the IEDs use themselves, the internal address, then this is something that is also used by the internal logics of the IED. So we want to use the free text desk field. And so all this information can be sent to the substation configuration tool. Yeah, we also have something similar, another matrix for the report control block assignment, where you can see that for every server IED, we have the sort of block, source block, with the IED name, and then we have the identifiers of that report control block, and then the client IED name to which it should be sent. But all this information that we're going to send to the substation configuration tool, it isn't so useful if we're then going to ask an engineer to sit there to check that it's okay, to upload it to the substation configuration tool, and then to export using a user interface the output files. So what we are going to do is, this is where it gets very, very interesting, is we have specified that the substation configuration tool, should operate on command lines. So imagine the case of a new substation. Once the central systems have automatically assigned the IP addresses, they've chosen the IDs, they've given the ID names, they've put all that information in the file CNF, then it shall send a command line to the substation configuration tool with an argument to create the new SCD file and a link for it to download that input file CNF from a shared database. Then it shall validate that file and go on to download the ICD templates which are referenced in that file. And it shall start to build the SCD file. In the case that it's not a new substation, but an extension, a renovation, or a replacement, then the difference is that the command line will also include a reference for an existing, the last active SCD file. And it will be the responsibility of the SCT tool to not only update the header section of the active SCD file with the last element of the history section in the file CNF, but also, and even more importantly, the SCT tool will have to make a comparison between both SCD files and decide, including checking the private sections of the ICD templates, and the SCT tool will then need to decide which IDs need to be reconfigured. Therefore, it must export not only the SCD file, but also a list of the IDs which need, a machine-readable list of the IDs which need reconfiguring. A point I want to emphasize here is that we will always ask the SCT tool to start from scratch. Even supposing it's just to add one new bay. And the reason for this is because since we are automating the process, the time is not really of the essence. We don't mind going that extra effort. And also it simplifies the interface, the customization that SCT tool needs to expect. So the SCT tool needs to be customized, but it needs to expect the same input all the time. So the SCT tool will send the SCD file and a list of devices which need to be reconfigured back to the central systems in a shared folder, which is referenced in the original command line. Iberdrola central systems will then recruit command line versions of the ID configuration tools of those affected INDs. It shall also proportion the relevant binary files automatically where necessary, and it will wait until a settings file has been completed for each ID. The protection settings is really the only part of Iberdrola's engineering process which requires a manual input. But even then, that manual input is very limited because the 90% of the protection settings we expect to be the exact same for each ID and bay of the same type. So we expect to have these standardized. But rather than asking our engineers to have to use a configuration tool and to manually get to know, to work with this configuration tool and to input these settings, what we want is to have a file, a specific file agreed between Iberdrola and the ID manufacturers for the protection settings file. And what this means is that we can fill out this file quickly, take advantage of synergies for synchronization settings or LDAP addresses, for example. And we can fill out this file as easy as possible. And once all the files are available, the SCD file and the settings file and the binary file, then the IED tool will be automatically recruited in order to create one single total configuration file. Again, this is a concept which is not part of the standard. This is something that Iberdrola is seeking to standardize, or at least to specify for our IED manufacturers. And why do we require this? That there be one file, or at least a compressed zip of various files? Well, if we have one unique file to upload, then we can do configuration hash checks between configuration files in our database and the one that's in the IED. And this means that, for example, that we can be confident that a configuration file uploaded by the system integrator during the FAT test is the same configuration file as the one which has reached commissioning during the SAT tests. And this is the guarantee that can allow us to reduce the quantity of SAT testing that we will have to do. Iberdrola is not so much specifying, it's something that we've seen that IED manufacturers can already deliver. It's something called an IP comparison check. So the IP which is in the SCD file is not used to configure the IP address of the IED. No, rather the IP of the IED, which has got to be configured locally in the first instance, is either done using the HMI of the IED or using the IED configuration tool with a local connection. But then the configuration file, which includes the IP address, will either be rejected by the IED tool or by the IED in the case that it is not consistent, that it is not the same. And then the total configuration file concept and configuration hash checks and timestamps to find out when the last configuration was loaded to the device is what allows us to know that the configuration which has been loaded by that integrator has not changed during the commissioning process. The substation configuration tool is a specific tender that we're currently ongoing with. And the command line versions of the IEDs tools are something that we expect of the IED manufacturers. Not needing aesthetic quality nor user interface, it does appear to be a relatively simple development for them, but with an obviously massive return for ourselves. In the whole engineering process that we mentioned earlier, we expect to save 49 hours per substation. And then we expect to save, in addition, 50% of our testing time during the commissioning process. And given, for example, that the single line diagram from the SCADA system has been the input for the file CNF, which has been the input for the SCD file, which has been in the input for the HMI, then we have one data origin between HMI and gateway, which means that if the system integrator has tested the point-to-point tests with the substation HMI, then we can be confident that that means that the gateway and the signals to telecontrol have also been configured correctly. And with the configuration hashes, timestamps for firmwares, configurations, and settings, means that we can guarantee that what is in the field is what we expect. And all this will contribute to another 50% reduction in testing times and costs. And moreover, the ability on top of all of this to do all our IED lifecycle management remotely means that we can, apart from corrective maintenance and IP change, means that we can save even more time and even more money during the life cycle. So at Iberdrola, we think that for distribution utilities, what will push the industry forward is to spend on and not to save on what's already abundant, what's already accessible, and what is already inexpensive, but rather to spend on those things in order to gain dividends in every single substation that we engineer, test, and manage. We think that it could be hugely beneficial if the 61850 standard were to include specific file type, such as the file CNF. And we are grateful for what the standard has already and what the industry has already provided us with, such as the later binding for Goose configuration, which is so important because it allows us to finish the Goose engineering in the SC2 tool and to automate it. And also the flexible product naming, which gives us better interoperability, but even interchangeability. And finally, total configuration files, timestamps, and configuration hash checks that allow us to guarantee the integrity of what's in the field. And last but not least, and what's really a revolution for our industry, is the command line versions of configuration tools, so that we can automate our processes and no longer have to have our engineers wasting lots of time battering through graphical user interface tools. Bill Gates once said that automation applied to an efficient operation is what will magnify the efficiency of that operation. Well, if you have an engineering process which is already based on standardization, on repeatable standardized templates, then you already have an efficient process. So if you want to magnify that efficiency, then you must apply automation as well. And if you are doing something similar, or if you see the same paradigm as we see in Iberdrola, and if you would like one-click configuration for your utility, then please get in touch with us, and together we can try and pressurize manufacturers in this industry to move in that direction. Because the biggest winners in 61850 will be those who recognise this paradigm shift and conserve the most precious resource, which is the time of our people.